Okay. All right, so the warm-up, if you can see it, is sine to the 7th over cosine to the 9th. And the hint on this is the degree of difference between the numerator and the denominator. How many degrees are there between 7 and 9? 2. 2. And what's the reciprocal of cosine?
Negative sine.
No, that's the no. Oh, you went to derivative. That's the reciprocal. Okay, yeah.
Secant.
Secant. Very good. Okay, so I'm going to rewrite this integral in the direction that Tyler was going, of sine to the 7th over cosine to the 7th x times 1 over cosine squared x dx. Does that seem like a mathematically possible thing to do?
Totally, but I would not, like, what, I don't know why you would be like, okay, to solve this, I need to do this now, but
Okay.
it makes sense.
I will show you in a moment. This is the integral of tangent to the 7th x secant squared x dx. Correct? Okay. This is where what you and I were just talking about, Jen, about always looking for an inner function and its derivative comes in handy here. Because the one we talked about just a couple days ago, but haven't looked at as much since, is, remember we used the, I showed you how the quotient rule, looking at sine over cosine, can give you the derivative of tangent. Does anyone remember what the derivative of tangent turned out to be after we used the quotient rule?
It was
Negative secant.
Not negative secant.
secant cos.
Secant cos would be 1. They're reciprocals of each other. One hint is the quotient rule. Okay, I need a new marker. The quotient rule.
Oh, it's secant squared x.
Secant squared x. One thing that honestly helps you remember that is since the quotient rule is u prime v minus uv prime over v squared. Remember we wound up with 1 on the top and we wound up with secant squared on the bottom. Okay? And that's, okay, so what we have, so the derivative of tangent is secant squared. So u is tangent x, du is secant squared x. What does my u substitution give me then? Integral of? I got a u here.
So you're not using to the 7th, you're just...
Well, not when I'm figuring out which is u and which is du, I'm not.
Okay.
Remember, the u is usually your innermost function. So if u is tangent, when I rewrite the integral down here, how do I rewrite this with these two substitutions?
Well, like, wait, so
U
du
is
is... So instead of just doing sec x, you're also with that, you're also deriving, anti-deriving the x as well.
No, remember we talked about transcendental functions? This x, you can't take it out.
Yeah, so
it's
where's the
present.
squared coming from?
This squared? That comes from using the quotient rule on tangent. We said, remember a few days ago, you saw in your notes, the derivative of tangent is always secant squared?
Oh, it's secant. Okay, I thought it was just secant. Yeah, okay. I just said that like 2 seconds ago.
All right, okay, and that's a clear 2, right? Is it? Okay. Hi, everyone's on a field trip. We're recording this one for the people who aren't here. Everyone's here, except for the Michelle and Daryl are on the field trip. Okay. Okay, so Joey, what were you going to say this integral turns out to be?
U to the 7th du.
U to the 7th du, and now it's just a products rule situation. And how do we anti-derive u to the 7th du? Anybody?
You do...
One
U to the 7th.
No wait, what? 1/8.
1/8 u
Yeah, that's right.
to the 8th plus c. Can I leave it like that?
Yeah, why not?
That's 1/8 tangent to the 8th x plus c.
How quickly I forget.
Okay, so remember what we started with. Sine to the 7th over cosine to the 9th. The key is, one of the hints might be that you see you've got 7th on the top, 9th on the bottom. Sine over cosine is tangent. So you're going to wind up with a tangent times a secant squared because that extra cosine squared on the bottom can be written as 1 over cosine squared, which is the same thing as secant squared, which is your derivative of tangent. So the u and the du are not really obvious here, but if you can rewrite it like this, hopefully you can see a u and a du. I know we only talked about that derivative once, we're talking about that again today. There are other ways to do this. I can think of a horrible way to turn this into 9 fractions, called it's a partial fraction separation trait we'll learn later, but not with 9 of them. And there's probably some other identities you could pull out to make this work, but my God, they'd all be longer and more difficult than the tangent-secant relationship.
Essentially, this calc test is giving us all these problems that essentially look the same, except deriving or anti-deriving, and what you're giving us this year is just a whole bag of tricks of how to figure them out. You know, they all look the same.
That's about 50 to 60% of the test, and then there's the word problems that actually apply this stuff to life, and we'll get to that.
I can't imagine any of this stuff being applied to life.
Oh, this is the first stuff you've ever learned that actually is applicable to life. Remember, this is all things that are changing. Up till now.
I think adding and subtracting is pretty.
That's true, but if you, you've done problems in your life about the car drives to, you get in the car for 6 hours at 50 miles an hour, how far have you gone?
Yeah.
But cars
Those are
really
my
don't.
favorites. Those are the only word problems I'm good at.
Well, they actually, remember in real life, cars stop, they slow down, they unfortunately hit trees. You need to know how fast they hit the tree. That's where this stuff comes in. Okay? That was your warm-up, and just something to remember, integrals, because we've been doing a lot of deriving lately. We're going to do more derivatives today, which will all require the product or quotient rule. There's no new ideas, so I'm just going to do some more difficult examples and apply to finding tangent lines a little bit. So, for example, here's a derivative. If I have f of x equals another dead marker. That's not what f of x equals. Some of these may be trick questions. Tangent x, cotangent x. What is f prime of x going to be?
Let me think, start. Wait a minute.
Oh, yeah.
Cotangent is 1 over tangent, right?
Tangent is 1 over tangent. So before we even derive, there may be some value. So what's that equal?
1.
What's the derivative of 1?
0.
0. Just out of curiosity, if you hadn't noticed that, let's go back to Jen's request a little bit earlier. Give you a quick list here. Anyway, you guys see, do you guys understand why the derivative of tangent times cotangent is 0?
Yeah.
Okay, that can be fun to see. If you hadn't seen that, here's the knowledge base you would have had. I'm going to write it slightly differently, give you a little bit of new notation. The derivative of sine x, if a sine is a function of x, it's a derivative of sine. Cosine. What is the derivative of cosine? Okay. We just did this a minute ago. What is the derivative of tangent?
Secant squared.
Okay. Did we do the, did anyone look up or work out the derivative of cotangent the other day when I mentioned you could find it the same way you found tangent?
Would it just be cosecant squared? If it is, that would be very smart.
That'd be a little too easy.
It's on my
Actually, it winds up being negative cosecant squared x.
Boy, what?
Yeah, well, I can demonstrate that one in a minute. That'll be a good use of the of our time. Anyone look up the now the derivative of secant? We did work that one out in class. Anyone remember what we got?
Oh, yeah.
Tan x sec x.
Yep, tangent x times secant x. And what about the derivative of cosecant? With if and if
let me see.
look at tangent and cotangent. Look at sine and cosine. There is a pattern. It's not the most intuitive one in the world.
Wait.
Derivative of sine was cosine. Derivative of cosine was negative sine.
Negative tan x cosecant x?
Negative cotangent x c
Negative cotangent x,
cosecant x.
cosecant x. Seems like between the complementary functions, the derivatives, okay, derivative of secant is tangent secant x. Derivative of cosecant, which is complement of secant, is negative reciprocal of tangent times reciprocal of secant. Or negative, I'm sorry, not reciprocal, negative complement of tangent, negative complement of secant. Derivative of tangent is secant squared x. Derivative of cotangent, the complement of tangent, is the complement of secant squared, but made negative, and also squared. Show you a little bit where that comes from. With this information, these three we talked about in class, these I said, these four we did in class, these two I said you could look up or derive on your own, but now I'm giving them to you. We could have done this one differently, and we should have gotten the same answer. Tyler, would that work for you following me to this board?
Yeah.
Excellent.
Totally. Just gotta move those books. There we go.
So if you hadn't noticed that you were looking at two reciprocal trigonometric functions, and you had pulled out the product rule, what's the product rule again?
U prime, v plus uv prime.
Don't mix up which is plus, which is minus. Then you would have said that f prime of x equals...
Wait, isn't it always?
No, the quotient rule is minus. Quotient rule is u prime v minus uv prime over v squared. Okay, so derivative of tangent, secant squared. V is cotangent x plus u, which is tangent x. Derivative of cotangent is negative cosecant squared x, right? Now this is like verifying a trig identity, like we did last year. Prove that this should really equal 0, if we've done it correctly. Have I plugged in my u primes and u's and v's and v primes correctly? I think so. All right. Sometimes the first thing to do with a trig identity that was useful was put everything into sines and cosines. Take this negative cosecant squared. When I multiply a negative and a positive, I get a negative, so that'll become subtraction. Cosecant squared. Okay, so that, I've got 1 over cosine squared times cosine over sine minus sine over cosine times 1 over sine squared. Is this going to work? Yes.
The sine is squared.
Yep, the sine will cancel out with that squared, the cosine will cancel out with that squared. I'll get 1 over cosine x sine x minus 1 over cosine x sine x, and what does that equal? 0. Life is good.
Wow.
Which method's faster?
The first one.
The first one.
The one where I was like, cotangent is 1 over tangent x.
That was the one. Remember the problem we did yesterday during tutorial where if you didn't factor, it was a lot longer than if you did factor first?
It was basically, it wasn't even a lot longer, it was like uncomparable.
It was a big leap. All right, let's go over here and look at some more examples of quotient and product rule situations, and how annoying they can get.
Okay.
Do another trig one.
Again.
I'll leave this list on the board for another month. Okay, another example. F of x equals sine x times sine x plus cosine x. Sometimes it's simpler to do some algebra or trigonometric identity stuff before we start. sometimes it's not.
We can't just distribute it.
You can distribute it, actually, and that may even wind up being easier. If we don't distribute, we'd be looking at u equals sine x, v equals sine x plus cosine x, and then we'd be doing the product rule from here. If we did distribute, would that get rid of needing the product rule at all?
No.
What would happen?
It would just be different values for each of them.
Yeah, it would be,
It would just be like sine x squared would be u, and uv would be sine x cos x.
very good, yeah. That's a good way to look at it. So that would be sine x cosine x. This one, I'm going to do this both ways actually, let you guys decide which is better. This we could derive as a single term. This one we'd have to use the product rule on again. Okay? So let's take a look at this. This one, u prime v plus